Hey guys, I'm back with the Circuit Hedron video podcast. But before I start, um, it's almost summer, and I'm gonna be vacationing a lot. So if there's no new videos for a weekend, a week, 2 weeks, whatever, then I'm partying somewhere. So that's too bad for you. So now on to the science. Today, as you can see, we're obviously going to be doing mass energy equivalence. What is mass energy equivalence? Mass energy equivalence is the concept that the mass of a particle is the measure of its energy content. So, if a body is at rest, then the energy is equal to its mass. If, however, it is moving relative to an observer, then the relativistic mass is equal to the relativistic energy, meaning that the mass relative to the observer is equal to the energy relative to the observer. So, as you can see here, if the body is not stationary, then the account must be made for relativistic. And relativistic basically just means, in a sense, I think, it really means that it's just relative to the observer who's observing this experiment or the mass or whatever, what have you. So you're wondering, where does mass energy equivalence come from? Well, as you can see, it comes from Einstein's famous E, which is equal to mc squared, E standing for energy, m standing for mass, and particle, c, sorry, what am I talking about, particle, c standing for the speed of light in a vacuum, in meters per second. But I'm sure you're wondering, how do we get E equal to m, when obviously m is times the speed of light squared, which is certainly not a small number. It's because in natural units, let me see if I can find that here, right here. The speed of light is set equal to 1, and I plan on doing a video of natural units in the future, and if I do, it'll be right up here probably, or somewhere around here. But anyway, in natural units, the speed of light, c, is 1. So that means energy equals to mass times 1 squared, so energy equals to mass times 1, and energy equals to mass. So there we go. E equals to m, thus mass energy equivalence. So now that we know what mass energy equivalence is, what can it be used for? Well, first, we're all familiar with the conservation of mass and conservation of energy. So if I take a particle at rest, mass energy equivalence, as you can hear, I probably just turned my script, allows mass to be converted to other forms of mass that require energy. For example, we can see, or that require energy or motion, such as kinetic energy, heat, or light. That means that like the particle is moving essentially. So it's like taking my hand, right, like I'm doing now. You probably can't see this, but here it's like this mouse here on the screen that you can see. And right now the mouse is still. So the mouse is going to have just a regular old mass, as you can see. This is somewhere around here. Here we are, okay. Rest mass. So, right now, my mouse has its just regular rest mass. Now, this mass can be converted into a mass that is now, such as that my mouse is now moving along the screen, so now it has motion to it. So, you can see that's what that means. It also means that if I input a certain amount of mass and energy into a system, some of it will all come out, the same amount will come out, except perhaps it will be in different amounts. So you can't convert mass into energy, that does not work. But you can convert matter into energy, so maybe some of that energy will have mass, so you'll get a different amount of matter and energy, but there will still be the same amount of mass and energy. So it's sort of like conservation of matter and energy. I'll try to sum this up here. Okay, so to sum it up, let me try this, that I can put mass and energy into a system in the form of a particle. All particles have mass, and they all have energy. So, well, not all particles have mass, like something like the photon has no mass. But okay, so we put something in like a proton, okay? We put it into a closed system, meaning nothing can escape. Say we have 2 protons, maybe. We do something to that system, I don't know, do something. And so we take it out. Now, we might have a different amount of matter and energy, but we'll still have the same amount of mass and the same amount of energy that we put in, meaning that maybe there's a couple of photons, which might have no mass, but they've gotten converted to energy, but maybe when the photons left the protons, which I'm not sure photons definitely don't come out of protons, make these protons electrons. There we go. Okay, or make it an electron and a positron, if you really want to be technical here. But since this is particle physics, the goal of particle physics is to be technical, so I guess we all want to be technical here. So maybe when the photons left the anti-electron and the electron, maybe they pushed the electron slightly, and since objects at motion have more mass than objects at rest, because as you approach the speed of light, your mass gets heavier and heavier, or greater and greater, I should say. Heavier is not, I don't think it's the correct word to describe mass. Let me know if I'm wrong or not, if you happen to be a particle physicist. Which, if you are a particle physicist watching my videos, that is really awesome, and you really have to let me know, because I will explode, quite literally. I hope not, but I probably will. So, yeah, please, if you're a particle physicist watching my videos, definitely tell me. But, anyway, as you approach the speed of light, you get more mass. So now, maybe, we have the same amount of energy, because some of the energy left in the form of the, photons, then that made up for that with the gaining of more mass, and mass is equal to energy right here, because mass, energy, equivalence, as you can see right here, mass is equivalent to energy. So yes, so if you're wondering, this is what E is equal to mc squared means. And just remember that mass cannot be converted to energy, but matter can, so that means that implies that some energy does have mass. But anyways, just remember, this is what E equals mc squared means, if you're wondering what is E equals mc squared useful for. If you're wondering that, you have issues. No insult to anybody that's watching my video, yeah. Okay, that's awkward. Even though I'm not actually talking to you, because I filmed this video, I don't know how long ago, from when you're watching it. We'll see. But anyway, so that is what E equals mc squared means, that energy is equal to mass, energy equivalence, and remember, C is equal to 1 in natural units, so that is how we get E, which is equal to M. And to summarize up what mass energy equivalence means that always if I put things into a system, they will have the same amount of mass, energy. Perhaps the numbers will be slightly tweaked, though. So, yep, that's mass energy equivalence. Thank you so much for watching. Remember, comment, rate, subscribe. Go to my website, quicknuclearscience.webs.com. If you don't have a YouTube account, you can comment on my videos there. All you need to do is put in your email. All of these videos in this Circuit Hadron video podcast series get uploaded to my website, so make sure to check that out. Thank you for watching. I hope this helps you understand mass energy equivalence, even just a tiny bit. Bye.